How are you doing?
Hi Kuldeep. Hi Kuldeep. How are you? I'm good.
Yeah, I'm also good. So, Vipul, just brief me like in 2 minutes your introduction. Like, what are you doing and what have you done in like your last month?
Okay, sure. So currently I am in Myntra and I am a senior big data developer or big data developer here in the platforms engineering team here, and we am responsible in the ingestion for the ingestion team. So here we basically have multiple sources that we get the data from, and we our job is to get the data and each every point validate the data and get each and every point to data warehouse. So, and it is overall a self-serve platform. So the user just need to come in, do the configuration, enter it, and then the pipeline will start. So I am part of this particular team here.
So, you have been mainly worked in Spark or mostly in SQL?
No, it has been a mix and match. So Spark also I have worked
Hmm.
quite well enough. Yeah. So just for the tech stack that I have worked on, it was include multiple sources. There were connectors, Debezium, Mongo source connector, and all. In the latest project I'm talking, then we have Kafka, then we have Kafka Connect as a framework we were using, and Debezium on top of that, and we were using Azure, and post that we use Spark, Scala, and data warehouse we were using Azure, and over that we were using Hive.
Okay, got it. Can you just start with a simple architecture of Spark? Like, how does it work and why companies prefer that?
Okay, sure. So Spark, basically earlier it was, I'll just take you back a bit before Spark. So there used to be Hadoop and there used to be MapReduce. So MapReduce was one of it was developed by Google, and company used to prefer that. So then eventually came a time that Spark got into preference and people companies starting preferring that. And it was because that it was an in-memory solution. And when I say in-memory solution, so what happened because with MapReduce or with Hadoop MapReduce, so whenever any data came into, so it used to write the data to disk, and then while getting the data, it used to again get the data from disk for any processing after every processing and before every processing, and that basically increased the latency of the job that was to be done, and it was comparatively slow as compared to Spark, which is an in-memory solution. So what happens is it stores the data in memory, which helps in getting the processing done faster. And hence the teams are going more towards Spark. However, there's still a catch that if a company has, let's say, huge amount of data, then spillage happens. So ultimately, the data gets out of memory and it gets into the disk. So we'll have to take a call here. So if the data of the company is very huge and if the resource constraint would be there or it could be too costly, then still Hadoop is used at certain places. But yes, Spark is a de facto standard as of now.
Okay, so right now you said like it's in memory. So can you just explain it like how it's in memory?
Okay, so when you say explain how it is in memory, as in the architecture of Spark, how does it happen, or what
Yeah, how
exactly?
does it process in memory, and why do we
Okay,
call this? Yeah.
sure. I'll just start off by explaining Spark architecture, and in that, I'll just delve into how it is in memory and why this is called an in-memory solution.
Sure.
Yeah, yeah. So Spark is a clustered application. So it's a basically a distributed. It works on a distributed architecture. So it has a driver, and driver there are multiple executors. So there are multiple nodes to it. So one is the driver, which basically runs the application and which which manages the code that is being written in Spark. And the others are the executors, basically where the real tasks happen. In each executor, we have two things: we have memory and we have disk. And in memory also we have two. um, I am just forgetting it, but yeah, there are two basically: storage memory and one is metadata memory or something, yeah, like that. So
Mhm.
what happens is whenever the driver assigns a particular task or a partition to a particular executor, it does some processing and keeps the intermediate results in memory rather than keeping it in disk. And
Hmm.
so let's say supposedly there was the RAM, the memory is 16 GB, and the data size and the data frame, we call it a data frame in Spark and all. So we use those terminology, data frame, RDDs or data set. So whatever it is, so it keeps it in memory, and it got into 14 GB. So 14 GB space would be used in memory, that would be kept there. So yeah, that is kept in memory. And for any transaction, so let's say there are multiple stages to it, stage 1, stage 2, stage 3. So it would be kept, it would be, so because it would be kept there only in memory only. Yeah, just to say. And why this is an in memory, why this is faster, because any random access from memory is faster as compared to disk. So it does not keep the data to disk until it is persisting on executor,
Okay.
or second stage if there is a spillage, I say.
Okay. So you said like data frames and all. So we have RDDs, data frames, data sets. So can you just give a difference between all of these three? Like why do we use RDD? Why do we use data set? And when do we use that?
Okay, sure. So these are basically three different types. I haven't worked on dataset as such, but yeah, RDDs and data frame. So RDDs, I can tell you the difference in RDDs and data frame. Yeah. So RDDs basically when we don't have a very defined schema, we
Hmm.
use RDD. We make use of RDD. And when we have a predefined set of schema, so let's say the case class in Scala, we use case class generally when we have a structured thing. So there's a different data type, struct data type. So when we have a structure defined to a particular uh, data that is going to come inside, then we use a data frame. So that is one of the major difference, because RDD does not have a predefined schema, data frame does have.
Okay. And what about data
And
set?
uh, data set, actually I haven't worked on, so I'm not very sure of exactly what is the difference, but yeah.
Okay. Okay. That's fine. Have you used somewhere cache and persist in your like office projects or somewhere?
Yeah, in my previous company I had I used cache, uh, dot cache function. So basically what it, so let's say a particular stage, so if I were to just to define the architecture of it, so there are three stages. First is jobs, then stages, and then task. Yeah, for each task. And we can so cache is used to basically persist the data set, or persist the data frame, in such a way so that it can be used in another processing, or it can be used in that particular uh, processing only it can be used. If so, I'll give you an example. So let's say we have to join two tables,
Hmm.
and in that there's a big table and there's a small table. Let's say there is two different tables, and I know that the second table, table 1 and table 2, and table 2 would be used in my another data frames also while joining. So yeah,
Hmm.
I will cache that particular table 2 data frame so that my computation would not be doubled down and doubled up.
Okay. So what do you think? The cache and persist both are same or both does the same thing?
Okay, so they obviously are not the same. That is for sure. They do different things. But actually, I have only used cache, but I
Hmm.
haven't used persist. Yeah. Uh, so
Okay.
I exactly don't know the difference of what.
Okay, okay, that is fine. So, have you used any optimization techniques in Spark? Like, have you faced any scenario? Can you share about that? Like, where you're stuck or where you're not able to process the data?
Yeah, sure, sure. So there were couple of optimizations that I did basically when I worked in my previous company, and in this also. So I would like to share one of it. So basically, our architecture was we got the data from multiple sources and we used to store it in files.
Hmm.
So, and it was an asynchronous API, synchronous API. So we stored in date time partitions basically. So it so happened at times, many a times, that for certain APIs, the data file was very, very small.
Hmm.
So it ranges into few KBs to very few MBs, like 10 MB or something like that. So the file size, and someday it got very big. So what happened that, and we were directly reading from let's say S3 bucket and make it into a data frame, getting it into a data frame. But what
Hmm.
happened that significantly when we saw that job run was taking much more time as it and as compared to an idle scenario, because the data amount of data which we were reading. So we found out that on processing that it's a problem that is known as a small file problem. So Spark is not very good optimized in terms of when we read too many small file and then try to process it. It is
Hmm.
optimized at to read a good amount of file which is around 128 MB or 1 GB, let's say.
Hmm.
File should be, it can be 1 GB, then it is very much optimized to read. So now the problem arises because so there were two solutions that we could have done. One was either at the storage level only, we could have combined multiple smaller files to make it into a big file and then let Spark read the file. A second would
Hmm.
be to read those small files and by make the use of futures. So
Okay.
basically, we could have multiple threads spawn over there to that these thread can simultaneously read the file, and we can use futures so that when a processing for a particular thread stops, it can add it into the future. So and this whole task can be done in background as opposed to the main thread being blocked. So this was one good optimization that we did, and the result of this was the job which was taking around 4 hours, it came down to 30 minutes.
Okay. Got it. And the
Yeah,
files were in which format?
they were in CSV and JSON. They were in both formats.
Okay. Got it. Uh, okay. So, do you have any idea on shuffling? Like, how does shuffle work in Spark?
Yes, I do have. So basically, shuffle, as I said, there are like first is job, then there are stages, and then there is task. So
Hmm.
basically, the distinction between them happens. So when there is any action, like say collect is an action or
Hmm.
sprint is an action, let's say these are actions. So whenever an action is performed, it divides the boundary for particular jobs. It sets the boundary for two different jobs, and within a job if there is a wide transformation that happens to basically distinct between different stages.
Hmm.
Yeah, different stages. So what happens is when the and within each particular stage there are different number of partitions is equivalent to the number of tasks. I hope I'm making sense.
Hmm.
Yeah, so there are number of tasks, so it goes like this. So whenever a wide transformation happens, so what happens is the data is stored on different executors or different machines. So whenever I say a wide transformation, it means when data from different partitions is involved in a particular processing, then a wide transformation happens. This can be by when we use a group by or a group by key, reduce by, or such operation which may involve different partition. And
Hmm.
shuffling is basically, and our data is stored on particular executor on particular machines. And when
Hmm.
data is transferred over the network to different executor or different machines, that is known as shuffling. Basically the data is getting shuffled and it is getting from one machine to another machine, and it happens in during wide transformations when we do.
Okay. Can you just give an example, like what comes under wide transformation and what comes under narrow? Just one example of any function.
Sure. So wide transformation is which requires shuffling. So let's say if I use a group by key,
Hmm.
that will come under wide transformation.
Okay. And
Mm.
narrow.
Yeah, narrow transformation would be to do an aggregate. Let's say if I want to do a sum.
Okay. And in the byte transformation, you said group by key. So there are a lot of key joins are there, like key transformations where there is group by key, reduce by key, sort by key. So what do you think? Like, why we have like three different types of things?
Okay, group by key, sort by key. So basically, there are group by key. So if we have a key defined, so these are basically the keyword is key here, and we have if a key is defined, so we can group by that particular key, or we can reduce by. I haven't used, and
Hmm.
sort by is also if we have that particular key, so we can sort the result into that.
Okay. Okay, so let's move on to something scenario based. So just assume like you are having a log data coming in your system, and that log data is coming, for example, to any bucket, like any cloud bucket, and that cloud bucket every day 1 TB file is coming.
Okay.
So just assume like it is having timestamp and everything. So what that file is coming to your S3 bucket or GCP bucket anywhere, and you have to process that data. But the issue is that the business is saying that we want data from last 90 days. Okay,
Okay.
so last 90 days data, if you check, like every day you are having 1 TB, so 30 days 30 TB, 90 days 90 TB. So you have a lot of data, and you can consider data in any format. But what will be your approach in solving the business problem? Like, how will you approach this?
Okay. So I have question here. So, what is the exactly the business problem? They want to get the data 90 days data is or
So
the storage
90
is the
days.
problem.
Yeah, so business wants a 90 days data, but that they can put any filter. Like, for example, they want a data for 90 days and they want a count particularly, or they want to put up a filter. So just assume that they just want a count of, let's assume we have a log data, and for example, some devices has been sold. So they want that devices to be grouped, and they want a count of those devices, like how many devices has been sold in those 90 days.
Okay. Okay. So, just to reiterate the problem. So, actually, they can perform any sort of operations on the data, but that
Hmm.
data would be only 90 days old, right?
Yeah.
Only the 90 days. So this is as per the requirement. They do certain set of operations on only 90 days of data. So it would be like, let's say we have 180 days of data. So before 90 days data, we can just erase it off or we can put it in cold tire.
No, no, we cannot. So they can ask for any 90 days for last 5 years. So
Acha, okay.
so particularly, let's assume ki we have a data that is like from now last 90 days data you have to process. So how will you process?
Okay, and now okay, matlab it says that the window size would be 90 days. They can read 90 dp of data. It can be of any time.
They need 90 days summary, but it depends on you how you would be reading that data. So you have to explain it from ingestion. So they are just putting up a data without anything, putting up a files or something. So you have to explain it from how will you ingest, how will you create a stage layer, and how after a stage layer, how you will process those data.
Okay, okay. Got it, got it. Few questions here I have. So, what is the data format? Is it the time series data or what? Time series database,
Uh,
it is? Since it is a log data, so I'm just assuming.
Kind of. So it have everything timestamps and all.
Okay, timestamp as the key and the whatever the log file or the log point would be there, that would be as a value, right? Okay, okay. And so this is already coming, or we have to get into the part where we have to ingest the data that is being generated on the machines.
No, no, that is already coming to a bucket.
That is already coming to a bucket. Okay, and the bucket is partitioned based on let's say if I were to assume it is on date, year, year, month, date, and hour wise, right?
Yeah, that you have to do. They are just dumping it.
Acha, they are just dumping it, so we have to have put a layer on that so that we can partition it, or we can deploy a strategy when they are dumping it to dump in this particular bucket only.
Okay, so you will partition that on which key?
Which T timestamp? Huh?
No, which column you will partition on, or how will you save the data?
Okay, yeah. If, for that question, I will take it as, since it is a timestamp is already there, and since log is already increasing, so I will take certain column that is ever increasing. Ever increasing would be, let's say, time column only. Basically, timestamp. I can extract the year part, the month, date, and the hour. If
Hmm.
that granularity can be kept, I'll be keeping that granularity, because that is something that always would be in an increasing manner only.
Okay.
Yeah, so that would be it. And just on one more question. So you said that per day 1 TB of data is generated, so it is a per TB or per day, or what?
Yeah,
Per
per
hour?
day around 1 TB. So it can vary, but
Hmm.
around 1 TB.
Okay, and when you say it can vary, so it can vary according to the time. So let's say certain traffic, the traffic at certain e-commerce website per se, the traffic is less at night and uh, good at daytime. So it can, basically, the partition can be skewed. So I'm just asking in that front,
Yeah,
or it
that
can be, it's a distributed thing.
no, it can vary. So they are just putting it in a data. So you have partition on which column right now?
Timestamp, basically timestamp, as in only keeping the date, the till the hour granularity, basically.
Okay, so you would not be doing any bucketing, or you would just be saving it just by a partition.
No, I would be, I'll be creating buckets based on these particular partition, like year, first bucket, and then inside those bucket, nested bucketing, basically, and those
Hmm.
bucketing, and we'll be keeping the files in this particular granularity at the R level. So let's say for R is 12 to 1, I would be
Hmm.
keeping one file, and
Hmm.
for another, I would be keeping another file, and so on and so
Hmm.
forth.
Okay. So don't you think this will also create one more problem that you told, like a small file problem?
Yeah, exactly. So that will create, basically, that I can have a different job in place just to keep the once the data. So that is why also I asked that it's a time series data. But yeah, since this is bucketing, so I can basically combine it. I'll use my first solution. Basically, when multiple small files would be there, I will be combining it into a one big file.
Hmm.
Yeah, or that can be solution. Or yeah, if we are to deploy in Spark, I would read again, can futures can be used, or certain other optimizations can be used, but it depends on the use case of it. How much amount of data we are reading, how frequently we want the data, how much that job is taking the time. These are multiple factors that we need to take care of.
Okay, so let's assume you have taken and you are saving the data per hour basis, right now.
Yeah,
And
okay.
every hour have one bucket, right?
Sorry, I couldn't hear.
Every hour will be having one bucket.
Every hour will be having one bucket. Okay, cool.
Okay.
Okay, and all
And
that.
that is the folder, right? And on the folder side, it is 1 TB, right?
Yeah, yeah. Hmm. Per
So,
day, one
okay,
TB.
now you got this data, you have bucketed, your partition, whatever you want to do. Now, how will you process the data? You want to take a summary of last 90 days.
Hmm. Okay. Sure. So last 90 days, first of all, though my data part is sorted. So my ingestion is done. I'm just thinking of that part. So my ingestion part is done here.
Yeah.
So my data is ingested, and it is. I don't see any challenges if it is because the small file can be one issue, and other issue would be how we can manage the data in terms of with respect to cost. But that is already taken care of. That is not something that we need to be handling in this particular call. Yeah, I think the ingestion part is sorted. Okay. Now, second comes is the processing part. So
Hmm.
we will be using Spark as a processing engine here,
Hmm.
and yeah, and we would be getting the data. We will be processing the data, doing such. So one more questions I have. One more question. So when you say the analyst want, so would there be ad hoc queries, or would there be predefined rules? Okay, so they want aggregates, they want sum, or they want count, or certain predefined rules, or each time the rule can be different.
No, it's a predefined rule and it's fixed. So, That's what I told. Like, let's assume like we have to group on product. Count of
Sorry, we
product
have
you
a
have to find. We have to find a count of product. So for example, today, for example, 40 cars has been sold. So you have to find for a 90 days, like how many that particular cars has been sold, that product. Similarly for
okay.
other products.
Sure, sure. So yeah, just so I'm thinking as a business requirement, it's very good that the analysts have predefined rules and all, but always there can come a solution. There can come a case where they might want to query on totally on the newer type or the newer data that
Hmm.
can be done, on a new rule that they want to apply. So
Hmm.
basically, what we will do is we will first of all we got the data and. Then we would I would like to follow the medallion architecture here, and by medallion architecture what I will do is this can be considered the bronze layer. Whatever the raw data that we have, that we can consider the bronze layer, and
Hmm.
post that we can have a transformation that can be done to standardize it, to standardize the log data basically, and get the data points out of it, and certain set of transformation that can be done to get it into the silver layer. Yeah, silver layer, and for we can have a gold layer that and the data, basically the OLAP tables can be designed according to the rules set by the analyst team, and we could define the gold tables, and that would
Hmm.
basically consider the aggregates for whatever aggregate they want on that particular data point. Let's say number of cars sold, number of this, that, the count, average, whatever this would be.
Hmm.
So these can be kept in a gold table OLAP method. So we can use the inmon or the kimball technology, kimball, whatever it is, depending. Yeah, so we can follow the medallion architecture here, and for processing we can use Spark. So what it will do, it will basically read the data from my S3 files, and
So you
then do a set.
just one question. So you would read daily every files one by one, like you
No,
have
no, it
every buckets, right?
no, no, yeah. So as and when the data comes, it would be read on a CDC basis basically.
Hmm.
It would be like we won't be reading data every day for
Hmm.
already read data also. So we would be
Hmm.
reading on a CDC basis, and we would be checkpointing it. So and by checkpointing it, so we would be maintaining a metadata or something checkpointing. So last run happened and we read this particular bucket. And also one more question, so how frequently this job would be run? Is it an is it a per day basis, 24-hour frequency job, or whatever the job would be?
Once a day, like whenever business wants it, they have to give that 90 days data.
Acha, whenever the business wants it, or the job will be okay, and whatever the buffer period. So let's say if the data is already present there, so they can expect a lag of 24 hours in it. Lag as in the data, the basically the refresh frequency. I want to know. It can
Huh,
be
that is
24
okay.
hours.
So you just have to give a 90 days data. That is okay, like if you're not giving today's data.
No, not given today's data. Na? ठीक है, हाँ, that makes sense. So if that is it, na, so we can use the checkpoint. We will be using the checkpointing mechanism and noting
Hmm.
and maintaining the metadata since last when we read the last day that we went read the data for. So one thing basically, and we will be processing it. And so let's say this is the first day that we happened and we read the data. We produced the silver tables, and
Hmm.
we did the aggregations and produced the gold table also. Now with gold table I mean the table that the analyst will use to query on, or that our solution will use to query. So let's say this particular 90-day, the sales of this particular scooter or car, let's say, is this much percentage, and whatever the rules basically defined by the rules. Now let's say the second day comes up and we have certain new entries that are basically a new file came up. Now we
Hmm.
will be using basically deduplication logic, and by deduplication basically we what we'd be doing, we would be merging on id column and keeping up the latest record. So that would be basically the truth of it, and would be keeping it in on the silver layer. And for gold layer we would be again aggregating on a daily basis, and we'd be using a merge operation,
Hmm.
upsert operation as we say. upsert operation. So by this, basically, we will have one particular final goal table, which will have the process data. So now, supposedly an analyst comes over and from a UI, let's say we have certain rules that were defined and he wants the data for 90 days. So it will just query over the data warehouse or data lake house, whatever.
Okay, so you have put up a filter, and every day you are filtering out the count and then upserting into last table again.
Yes, yeah.
Okay, got it. Okay, so let's move ahead. So have you used this Spark SQL, data frames, all of these things, or mostly you have used the data frames?
I have mostly used data frames.
Okay. Do you think there are any trade-offs between Spark SQL and data frames?
No, I don't. There would be trade off because
Mhm.
Spark SQL, as far as I can understand, because Spark SQL is plain SQL and then uh, it will again convert to an intermediary step. And Scala is directly basically Spark is written in Scala only. So APIs
Mhm.
would be much more faster and the latency would be less. So the operations would be performed, I think, more in a Scala data frame as compared to a Spark SQL.
So stages would be different for both.
Sorry.
The number of stages that are being generated, so it would be different for both.
Uh, I think so. It should be same. The stages should be same. It's just that the network call, the network IO operation, that would
Hmm.
take in some time for the conversion and that will add up to the latency. But the stages would be same because the Spark internally uses Catalyst optimizer. So basically, what it will infer and it will create the DAG, and DAG internally would basically capable enough to measure what are the stages. What are the stages and what are the checkpoints before which it need to divide the stages to? What are the white transformations? And these are common.
Okay, okay, got it. Okay, I'm sharing you one link. Let's join that so we can cover Python also. So
Sure.
you are working with Python or Scala? What language you are comfortable at?
Python.
Okay. That's shared in the chat. Uh, okay. Can you share or
Yeah, yeah. Is it sure? No, present. Yeah.